The recorder's on, Dave.
Yep. So we have a diversity of different types of drives to take a look at here. So it took us a while to get the proper MegaRAID storage manager. The one that you played with a couple weeks ago, for some reason, did not work with these newer systems or whatever. So over the weekend, I basically did some testing. So using the MegaRAID storage manager, I see we got Seagate drives. They were spinning at 7,200 RPM with a 4 millisecond latency, 6 gigabit per second rate. And I shared the link of where it is, or the specs for it, so to speak.
Right.
So I have a variety of different things to do here, but talking to Steve, he wants capacity, so RAID 5 versus RAID 6 is what he has decided. So I gave him two choices. We can have 5 RAID 6 that were 8 data drives and 2 parity drives. Now this gives us 2 checksums. And there's something called silent data corruption that some people, and this is what Tom wanted RAID 6 for. So with RAID 6, number one, if 2 drives go out, we can recover the file system, but also with 2 checksum errors, we can correct things that might not have been correctable with 1 checksum. The other choice then was 6 LUNs that were a RAID 5, 8+1, and that gave me 438 terabyte. So I got to keep Steve happy. I mean, he spent $100,000 and has about a 1.2 petabyte of data, and he's only going to get 365 or 438 out of it. Keep in mind, we have 2 copies, so we lose half of that petabyte just in the copy, right?
Yep.
And then we lose stuff to parity, and we lose stuff to the metadata. So I actually went through, built them to get the actual numbers. So Steve decided RAID 5 8+1, 73 terabytes per LUN. Let's scroll down. The first drawing here. Oh, so this was 1 drive. Notice it slips from the left to the right. In fact, you can almost see tiers in the red where it's at like 216 and down to 189 or something, down to 162. You can see how it actually has levels. This, to me, tells me this is what's referred to as a zone bit drive, meaning that the far left is the beginning of the platter on the outside circumference. And as we go to the right, we are indexing into the drive. So the 0% to 100% is positioned into the drive, logical block offset.
Okay.
As you go towards the center of the drive, it's a smaller circumference, and they put less sectors in that rotation. We'll come back to this. So as I go towards the center of the drive, my bandwidth is going to fall off because a single rotation has less sectors underneath it. And you can actually see 1, 2, 3, 4. I see about 6 zones on this drive. I'm counting the red. I'm counting the little plateaus on the red.
Oh, I see. Oh, wait. So
go ahead.
So basically, what you're one way you could determine the zones would be just to look at the performance, and if it's when it's comparable, that's going to be a zone because everything is adjacent.
Not adjacent is the same number of sectors per rotation, per track.
Oh, I'm sorry. Yeah.
So it's not adjacent, but in a single rotation, I'm picking up more blocks, more sectors. Okay? So on the outer circumference, it's a bigger circumference, and I can pack more sectors in that spin, in that single rotation. As I go towards the center of the drive, not enough circumference to pack as much. Okay?
I just had a light bulb moment. This makes sense.
So this is what's referred to as a zone bit drive. Large drives and Seagate drives typically have this kind of behavior. And basically a zone says, from 0% to about 20%, we have a given number of sectors in a rotation or a track or a cylinder. And then somewhere about 20% to looks like about 50% is another zone. And then somewhere around 55% to about 72%, I see another zone. And then somewhere around 75 to about 90%, I see another zone. Meaning that those zones, basically a single spin is going to have a given number of sectors picked up in that single rotation. And there's more sectors in a rotation on the outer circumference than on the inner circumference. Okay?
Right.
So that's why that's my interpretation. Then I could double check it, but that's why you would see something where the bandwidth falls off as you go towards the center of the drive. Now later, we're going to come back to this, but I want to measure this and stuff like that, but I don't know what the request size is on this tool. And this tool is single-threaded. This is CentOS's disk utility off the desktop, and we'll get into that later. So I was getting about 197 megabytes per second, 500 samples. I could up the number of samples. I can do a variety of things to it. But there's also the sample size of 10 megabytes, and I'm not sure. I don't think that's the request size. I think that's the size of the file. I need to get into strace and profiling it. You remember that one drawing that had all the bus stops or fire bucket brigade? I want to get into that drawing and chase this tool all the way from the application to the spindle.
Sure.
So anyway, let's scroll down. Next drawing. Try to pick through these. So now I took that drive and made 4 of them. So I'm in the MegaRAID Storage Manager, ripped apart the one LUN. Actually, I went in and just built a single, a 4-way, an 8-way. I built as many as I could before I ran out of drives, tested them, and then went back and destroyed a couple to build the additional RAID types that I want. So I'm just pulling up some different numbers here. So this is a 2-way stripe. It's actually a 256 megabyte request size versus 255. That's a typo. I'm going to come back to stripe units later. Let's leave that alone. But basically, if I do a 4 megabyte request, that 4 megabyte I/O operation will get broken up into stripe unit chunks. Now go back up for a second. Where were we? That's good. So we both reads and writes were at about 430 with a 4-way stripe. Okay, and we were at 100 before, so we're getting pretty good scaling there. Remember, the prior drawing was about 100 megabyte. Now we're at about 400 megabyte. The latency hasn't changed. It's still a 12 millisecond. It's gone down just a little bit, but it hasn't changed much. And again, if I were to go from a 7,200 RPM to 15,000 RPM, my latency and access time would go down. But these drives were picked for capacity and bandwidth, not for latency. So then the next one, so we were at 400. Reads and writes were the same. Now we're at RAID 5, and the reads are pretty good there, even better than we had at the stripe in the 500 megaset range. But look at what happened to the writes.
Oh, wow.
That's your write penalty. That's referred to as the write penalty. So every time you write, you have to generate parity.
Yep.
And that's what you're seeing there. Okay? And I can see a little bit of that zone bit drive behavior in that RAID 5 as well. Let's page down. So I was just going through. So here's RAID 6, pretty much about the same. There was a subtle difference between the two. I don't want to nitpick about it. But again, you can still see at RAID 6, the writes are significantly lower than the reads because of the generation of the write parity. And it should be a little bit lower because you got 2 parities to write. So now I took the same thing and did an 8-way stripe. But these are 100 megabyte per, and now we're scroll down just a little bit. So an 8-way stripe, now we're writing instead of at 140, we're writing at 540 megabytes per second because we don't have to generate parity.
Yep.
But we're 8-way stripe and we're not getting 800 megabyte that the drive was rated at.
Mm-hmm.
So that is something that we'll look at later and see if we can actually optimize to make sure that it's able to take advantage of an 8-way stripe. I didn't want to do a lot of this stuff without you, but that SCSI block layer and that elevator has a max request size in it.
Oh, I remember.
If we up that, we might be able to get it to be more friendly to an 8-way stripe.
Ah.
So there will be tunings that we can do. Again, it's an efficiency question on the fire bucket brigade. Go ahead, keep going. Oh, where are we? So this was a 8+1 RAID 5. We were 4 before. That's right. We were at a 4+1 and 4+2. So now and then we went an 8-way stripe. Now we're in 8-way RAID 5. And so again, you can see the write penalties, no change on access, but the read rates are only about 400, where again, at an 8+1, we got to make sure that our request size are optimized for an 8-wide stripe. And we have not confirmed that. So keep in mind, every one of these specs we're looking at here is request size dependent, right? So let's just go and take a look at RAID 6. So RAID 6 again, 400, 134. You can see the RAID 6 drop the write down just a touch. And again, I need to go into max sector kbytes and stuff like that in the block layer to see if I can get the actual IOPS going to the RAID controller to be an 8-wide stripe, not broken up by the SCSI block layer. Now, I'm going to use an 8+2 on DMF because it's smart enough to do all that stuff. Okay? And we'll get into that. Let's scroll down. So now I did 1+1 RAID mirror, same drives. So now we're in a mirror, and we do have better writes than a RAID 5. Not much. Disadvantage of mirror is you lose half your disk space.
Right.
I don't know what else I have to say about this. The access went down a couple of milliseconds, but I don't really care. Let's do a 4+4 RAID 1.
Yep. Huh.
So you're understanding my terminology. So I've got 4 drives and a mirror of 4.
Yep.
And I'm using RAID 1 to describe this because that's what the GUI was calling it versus RAID 10. We'll talk about that later. So RAID 4 mirror, look at, we're getting really good now. Write averages of 400, and each of these drives are at about 100 megabyte per. So we're getting much better write performance on this RAID. But again, twice the cost, twice the disk space. Okay? And I'm just trying to generalize things. Like I say, to put this, how do you put all this data into a chart to represent it and also include request sizes and single-threaded, multi-threaded, single and random? Let's go on. So there's my 8+8 RAID +1. And again, we're not getting full 800 meg, but you can see the writes are really cranking up there. And again, I suspect if we go in and adjust the layers, in particular the SCSI block layer and the elevator, we could get more bandwidth out of that. Okay?
Yep.
Let's just go on. So I just went off and took a day to do this. I did go 32 wide. And again, this might be fun to play with and profile and try to optimize, but we were getting, look at that, our writes are really good here at almost 700 megabyte per second on writes, but our reads went down.
Yeah.
And it'd be interesting to dig into that. And again, understanding request sizes and things of that sort. Now, the next drawing, so I'd say, well, wait a second, I got 32 capable of 100 megabyte per. Why aren't I up in the, 2 gigabyte range or something like that, right?
Mm-hmm.
So then I upped the request size. So scroll to this next where we're just starting to see it. Notice the sample size. So I went from a default, I was just using a default of 10 MB. And again, I don't know how that relates to the request size really. I did not profile it with things like strace or anything. So I don't know what the tool is actually doing. But look at the sample size is 512 megabyte, and now I'm up in, what is that? Almost 4 gigabyte, right?
Yep.
So 3.2 average writes, pretty good compared to what we were doing before. Again, there's no recovery, there's no protection, there's no RAID here. So I haven't profiled this tool to understand when I changed the sample size from 10 megabyte to 512 megabyte. In fact, 10 megabyte is human friendly. I like 1024, for example, to pick powers of 2. Keep in mind, everything out there is in powers of 2. All these buffers, all these buckets, all these things are in powers of 2. So 2, 4, 8, 16, 32, 64, 128, 256, 512, 1 meg, 2 meg, in power of 2 numbers, 1024, that sort of thing. Those are the hardware friendly numbers.
Yep.
So instead of doing like 500, I went to 512. And technically, I'm not sure that's a kbyte request size. It's just marking it as a sample size in megabyte. So I really don't know what I was doing there. I just had to mark the difference there. See the difference? So the sample size was 512 meg, not a 512 kbyte request size. I just was kind of correlating, thinking that maybe they were. You follow me?
Yeah, I do.
So the default was a 10 megabyte. I went to 512, and I assumed it had something to do with request size, but I don't know that. That's probably a misnomered label. Let's go on. When we're really getting pretty good, they're getting close to 4 gigabyte per second. Now I took the NVMEs. So we're done with the Seagate drives that are behind the MegaRAID controller. Now what do we got? Take a look at that access time.
What interests me the most is how things diverge at the end there.
There are some interesting artifacts, yes, and I ran it 3-4 times to see if that was changed. And this is when I would run off to Tom or somebody else to say, tell me more. I don't have any NVMe trimmers or anything like that running yet. I don't really know what needs to be running for these devices. Okay? But I'm getting one of these devices getting a write of a gig. The writes are better than the reads. And again, 0.09 milliseconds. So where I need latency, this, again, I had to choose, okay, this is an NFS home server. Let's put home here, right?
Yep.
Sure, I could put the DMF database engine here. That would fit better. But I don't expect DMF to be hot and running all the time. I expect NFS to be hot and running. So I'd rather use this high quality asset for home rather than the database. Does that make sense?
Yeah.
So even that 0.09 would be great for Postgres. I got these devices and I just think it's best to use them for home. Let's move on to the next one. So then I did a RAID 5. When you're building the RAIDs, it asks you for your chunk size or your block size and stuff. Well, what are we getting here? 4 gigabytes in reads and only 1 gig on the writes. Again, you have write penalty now because you're in a RAID 5.
Yep.
Now, I think I plan on using RAID 5 for home. I'll still live with 1 gigabyte per second on the writes. And again, my applications should not be doing Scratch I/O to home. They should be doing that Scratch I/O to like SAN SSD or something. So I consider it important enough for us to put RAID 5 on home and take the penalty. And fortunately, we've got these nice devices to do that. Okay?
Yep.
So you can see the big effective write penalties there as well, generating the parity. Let's go on. What's the next one? So now I did them as a RAID 10. Basically, the way the software did this, basically it created a 3+3 RAID 10. So we had 3 spindles and then 3 mirrors. They gave me a 1.1 terabyte capacity. Well, I forget what the other one was, but we'll come back to that as needed. But here now, my reads are in 4 gig, my writes are in the 2 gig. So again, this is striping with error recovery, but I've lost half my capacity. Questions? Let's look at the next one. Go ahead.
Okay, so the part that I'm slightly confused about is, so with RAID 10, what RAID 10 means. I think it made
Stripe, you mirror and then stripe.
Okay.
So we take 2 drives, mirror them, 2 drives, mirror them, 2 drives, mirror them, and then stripe them together.
Okay. Okay.
So
perfect.
RAID 0 is just striping. RAID 1 is mirror, and then RAID 10 is a combination.
Yep. That makes sense.
So I take 2 drives, stripe, 2 drives, stripe, 2 drives, stripe. Or I'm sorry, 2 drives, mirror, 2 drives, mirror, 2 drives, mirror, and then stripe them. And I didn't like a 3-way stripe, but I only had 6 NVMEs.
Okay.
Okay. And again, I lose half my capacity, but my writes are better.
Yep.
Because I don't have to generate write penalty as much. Scroll, what were we? There. So we were at 2.5 gigabyte for writes, 4 gig for reads. So then I did it and took, okay, I've got 6 of these things. Let's just make an LVM stripe. No error recovery. I just took the 6 drives. So now I'm sitting there at almost 4 gigabyte per second on both my reads and writes, but no error recovery. So I'm willing to go RAID 5 and drop my writes from 4 gig to 1 gig.
Okay.
Because again, I don't have enough NVMEs to make a mirror. Okay?
Yep.
Nor do I have enough to make RAID 6. So I'm balancing all this stuff, including, again, I still would like to hear from Tom and Steve. When you bought these things, how did you think you wanted to use them? I have my ideas, but what was your thinking, right? I've got to keep them happy too. I've got a sanity check every along the way and say, are we on the same page? What's going on? So now I'm into the SSDs. Okay, so the header's on the prior page. This was just a single SSD, I believe. Go up just a notch. There we are. Yeah, it's just a single drive. So these were the DMF drives that we were using. Go ahead, go down. So there's a single drive, 500 meg instead of the 100 meg that we were getting out of the Seagate spindle drives. Keep on going. Reads and writes about 500 meg. Keep going. And then here's the root disk. Go up just a little.
There we go.
So these are, it's called a DOM, a disk on module. They're real small. It's not a disk bay type of thing. So this is our root disk, and we're getting about 400 on the reads and 200 megabytes on the write. Just again, I wanted to document everything. When I'm actually getting into the workload, I want to understand, and measuring things, I want to understand potentially what I can get, and that's why I measured. And again, these measurements were only on one request size. Let's go down. So there we are with the 4 terabytes that just came in. Looks like about the same, just a little bit faster, 500 instead of 400, something like that, just a little bit better. Let's look at the mirror. I only had 2 of them, so I can only mirror. And again, mirroring, we're getting close to 360 gigabyte per sec or megabyte per second. Go on down. So then I did a 2-way stripe, close to a gig. That makes sense, about double what we had before. And then go to the next one. Now, instead of a stripe, I got a linear. And it's kind of interesting, again, like you say, the artifacts after 60% or something. But 500 some for the reads. A linear is a concat rather than a stripe. So we're going to fill up the first drive and then the second drive.
Mm-hmm.
Called linear or concatenated. Allocation groups will still, if these are two drives, allocation groups will still spread the allocations across the two drives, but it's not a stripe. Let's go on. And I think that pretty much covers it. So in my mind, I've got a home directory, and I'm looking at that kind of being random IO, a few threads, but not single threaded. And then I've got a /archive for large sequential assets. So that would be only a couple again. Unlikely that you're going to have more than 2 users pulling stuff out of archive at the same time with our, workload. I'm kind of done with this whole discussion here, but it'd be nice to be able to redo this with 10 request sizes and 12 types of IO patterns. Use RAID 0 and 6 instead of RAID 3, and be able to get into heat maps and actually put numbers in there or some sort of color grading so that there's a better way to represent the information that I have here. Again, this just goes back to, I'm not going to go RAID 5 for lots of little IOPS. That's going to be bad for me. And we need to, later in our mentoring, we'll get into measuring different request sizes to see what the optimal file system design is for that type of IO.
Yep.
Done with that. Comments, questions?
Okay, here's one. Actually, a couple. First off, what did you use for doing these benchmarks? Was this PCP or what?
It was, no. It is a desktop GUI within Red Hat and CentOS. It's not available in SLES.
Okay.
So right. I'll get you running it later, but basically you can go up on your CentOS desktop and pull out down applications, and in there is a disk thing.
Oh, okay.
Let me hang on here. Let's get a VNC running to one of these. Hang on. So I want to get a VNC into either NFS server or Ford.
All right.
I'm on Ford right now, but we're going to blow this. This is the one we're going to install here.
So the one I'm going to is 10.1.10.8 for VNC?
No, I hang on. So go to 10.1.10.54.
Okay.
You could have gotten a desktop on that one, but I was using VNC instead of the web GUI desktop.
All right.
And then display 2.
Sure.
And SGI is the password.
Hold on.
Hang on. So it's :2.
Yep.
Did it respond?
It's refusing.
Hang on. Try again.
All right.
It was a vanilla installation. The firewall was up.
Oh, okay.
I did an IP tables - capital F for temporary.
Mm-hmm. Okay, I'm in.
Go up under applications and down to system tools. Nope.
All right.
One more, I guess. Utilities. Go to utilities. And there's disks. See it? 2 up. Okay, so go ahead and select, it doesn't matter, select any one of those block devices. Now go up to the menu in the upper right, and there's benchmark. And then start your benchmark. Now it's probably going to complain. So here I was putting in 1,000.
Okay.
Go ahead, put in 1,000. And then again, I was just using the default sample size, mostly to just save time, so I don't have to do it with all those 30 different runs that we did. And that's expected because these are NVMe. Close out of there. Close again. Is there another device it didn't like this? It's just kill it and go back in again. Yeah. There you are. And let's pick that one, for example. No, let's pick one of the top ones. And you're running a test. Now I want to come back to this later and actually profile it to see what it's actually doing and stuff.
Okay.
But this is just to demonstrate how I got to it. So I was using this because I can get a quick plot.
Sure.
And that allowed me, within half a day to be able to fire up all those different tests. There are lots of other tests, and FIO is the one that we're actually going to stress because that can do asynchronous I/O and memory mapped I/O and a variety of other things, and would be ASCII, and then we got to figure out how to plot it if we want to. So you're done. Let's close out of that. Okay, so that was how I did the test.
All right.
And by the way, I was cheating. I would bring up SLES and use YAST to build all of the different file systems instead of command line. And then I would reboot to CentOS to get that tool. CentOS doesn't have a GUI. It used to. I can't find it anymore. It used to be called Disk Druid, and that disk utility didn't have the ability of building MDs and LVMs and stuff. So that's why I was flipping back and forth. It was easier. Questions?
None right now.
Okay, so that's how I got that. And again, I just pulled that one up because it was a quick way to get a graph. Go ahead and get rid of that. And check your email. I did a
yep.
So here's our specification. And I was trying to get Tom and everybody to buy in and, tell me, well, here's what I'm planning to do. I had to ask for phone calls to sort it out, all kinds of things. Nothing ever happened, priorities or whatever. So I just have to go on with my own. I originally wanted this vetted with SGI before I build it, but at this point, let's build it and then let Tom and them vet it at that point.
It works.
So this should be Ford 1 at 10.1.10.8.
Okay.
It's going to be put at 10.1.10.54 for now, but eventually will be at 10.1.10.15.
Okay.
DNS gateway. When we redeploy this new box, I'm going to have to move DNS from FCL server to this new box and swap out the old FCL server. Okay?
All right.
So the OS, and again, I'm going to grab the OS from 10.1.10.15, install /11sp4. I do need compatibility libraries for MSN. It does complain on the Simple Network Management Protocol. By the way, I did have a lot of crashes and stability problems. We'll see what happens today, but you got two choices when you do your first install: simple and quick and fix it later, or try to do everything all at once, and if it blows up, you've wasted a couple hours.
Sure.
So we're going to try to find something in between there. But when I wanted to install KVM just so that networking and it's available for KVM should I want it. But then that seemed to be causing some panics and stuff. So I'm going to try to do that. But if we start getting panics, I'm going to back off on that. For a while, I thought it might have been the NVMEs or something. But anyway, eventually everything got installed and I moved on. So I need to install the file server software, the GNOME desktop, C compilers, and I don't want any of the security AppArmor.
Okay.
I do want to get updates. I do want to get the SDK installed because we need Git. I'm going to need the Oracle JDK. I'm going to need Foundation, and I'm going to need ISSP. And I also need to grab the SGI NVMe tarball and see if that will help me on this platform.
Right.
It's an SGI spin of the RPMs, but they should be out there somewhere else as well. I don't know the differences between what might be in the SLES versus what SGI gave me a year or two ago. We're going to have to grab the MegaRAID Storage Manager from MCL Server, so I've got a CD. This is what took us a while to find it, and I was asking Tom to find it, but he's been under the weather. So we're going to mount any .ISO is a CD image or DVD image.
Yep.
Okay? So I can burn a .ISO. That .ISO is what I send to a burner. So I can mount that ISO as a -O loop and then CD into that mounted ISO. Okay? There's another thing on that ISO that we're going to have to grab is called SuperDoctor. So this is a super micro product for the Simple Network Management Protocol, SNMP. Have you heard of that? So that's for hardware events and things of that sort. I haven't played with SuperDoctor, but that's part of our instrumentation to be able to say, send me email if you got a temperature alert or a voltage problem. Okay? I'm going to need to register the system. And again, I'm trying to give you the spec sheet for all of this. And also, I may want kernel debug info, but right now I am not able to get these boxes to KDump. So I don't care. I've been spending a couple of days trying to get it to work, and it's always broken. SGI had their own fixes for it. I tried those, and that didn't help either. So I'm not going to... Basically, if the system hangs or something, I'm dead out of luck and no way of knowing why it hung. The other tool I can't get working is called KDB, such that if it hung, I could drop into the kernel debugger and see what's going on. That also is not working on this box for some reason. For me, if a system is unresponsive or hanging, I'd like to get as much signature diagnostic information on it before I reset it. That way, if it happens again, I could say it's the same signature. I've got a pattern here. Okay?
Yep.
Then we're going to do a zipper update. So root password we're going to specify as SGI. I'll get into kernel modules and SGI post upgrade later. Scroll down. So I was trying to get the specs here. I don't know, did you get a chance to print this?
No.
Okay, well, anyway, scroll up just a little bit. I was trying to give you all the information you'd plug in. So volume groups, right there. So we're going to have a root A volume group, which is our DOM. We're going to have a DMF home and a DMF journals, which are the 1.6 terabyte drives. We're going to have a home that's the NVMe. We're going to have an archive. Now, right now, I'm putting archive off in the RAID 10 terabyte drives and not considering the 4 terabyte of SSD that we have. So right now, the archive is off in the MegaRAID. Then MSP DSK1, that is the file system that data migration will put all of its assets into. And the database that's in DMF home is going to describe where files are out in MSP DSK1. Okay?
All right.
The second box and the second copy of these assets, so that we've got two backups, will be MSP DSK2. So we're going to mount the NFS server, MSP DSK2, on that box and mount it on FCL server. So we're going to write to one of our set of RAIDs and write to an NFS server with the other set of RAID. Does that make sense?
Yes.
And I don't have it working yet, but I wanted a third 10 gig dedicated just for that NFS. So 10 gig to 10 gig without a switch, just connecting to the two boxes. So the first 10 gig would be for NFS to home and archive. But the second 10 gig would be dedicated just for DMF to write into NFS server. You follow that?
Yeah.
Not too sure?
No, I'm not.
Anyway, the other volume group we need, DMF MoveFS. We could also put that on the SSDs, but MoveFS is when for example, we could put up DMF with just one MSP right now. And my plan right now is actually to wait on the second NFS server and play with that box for a week. And then add in the second MSP and then clone the first MSP off to the second MSP. And that's what MoveFS is for.
Oh, okay.
So that would be to clone from one MSP to another.
All right.
Okay. So those are the volume groups, and then the logical volumes within that. We need root, we want temp. I'm trying to keep, oops, you went too far.
All right.
There, that's good. I'm trying to keep temp from filling up root. So that's why I put it as a separate volume. And then swap, then home, then archive, MSP1. And then we also, for data migration, have to have the DMF home, DMF journals, DMF backup, DMF temp, DMF spool, LiveArc, and MoveFS. These are names I'm arbitrarily picking. They were the mock-up that we had on Trillion.
Yep.
Any questions?
None so far.
So our 128 gigabyte DOM drive, I'm going to put a gig for boot that's got to be extended 3. By the way, I am still having problems jumping from BIOS to the NVR. And right now I have separate PXE boot files off on FCL server for each box. We'll take a look at them. So I am now PXE booting rather than depending upon /boot to get the systems booted.
Okay.
And we'll talk about that later. Again, I got to pick a number, but I wanted temp separated. So I said, well, let's put 80 on root and 30 on temp. That was pretty arbitrary. And I bounced the number around. We may even do it differently. And then everything that's left over for swap. Okay?
Yep.
So then my home, I've got 6 NVMEs. I'm going to make them RAID 5, and I want a small chunk size. I want this to be designed for smaller files, a home type of design. Now, this file system, right now, I am not going to make it managed, and I'm not going to start DMF yet, but we're going to install and configure it, just not fired up yet. And also in /home, there are things about MakeFS options and stuff that we could consider. I'm leaving it all alone. How I export it, and also I'm seeing there my FS tab options, defaults, and then you see DMI. You see that DMI? That's what it says it's data migration managed.
Yeah.
/archive.
Yep.
I right now am going to do a 4+1 RAID 5.
All right.
And these are not going to be dev. They're going to be from the RAID disks, not from dev NVMe. Okay. It'll be XFS. And again, that's where the genome data, Department of Justice data, and the large assets are going to be put as a /archive concept.
Okay.
Then our DSK MSP1, we've decided on 5 8+1 RAID 5s, giving us 356. Oh, I've got some sort of typo there. I was trying to say 256 KB stripe size, not the actual unit. Fix that 356. There you are. Change that to 256. So 5 times 9 gives me 54 drives. There's 6 left over. But I've got to use one of them for MoveFS, and I'm going to use probably 4 of them for /archive. No, I said 5. I said 5 there. You following me?
Yeah, I do. This is good.
So then this was the mock-up that I had from Trillian and what the device or the volume group and the logical volume names were and what they were in size. I'm actually upping them a little, but let's just move on. So I need to register. This is kind of your checklist. Register and update, reboot. I don't want to go too far. I want to make sure that we don't lose reboot capability. After I've got the system up, then I got to set up my ITSI message of the day, ITSI hosts. I want to make sure that I got turbo mode on. We're going to leave hyperthreads on.
Yeah.
I got configured the second drive, and those are working. I can ping, so they are physically connected correctly. But the third 10 gig between them, I have not been able to ping between them, and I'm not sure what Tom has plugged into.
Okay.
And I've got 2 subnets for the 10 gigs, a .10 and a .20.
Yep.
Okay. Then we got our DMF.conf and DM check. That still exists on Trillian. I'm waiting for a license. We're going to have to renew the license every 6 months. Steve says they won't give us a permanent license, but they will renew it every 6 months.
All right.
We need to set up the network time protocol, NFS server, NIS client, NIS server. So we're going to actually clone over from the actual FCL server the NIS configuration we looked at in a prior session. And DNS as well. And HTTP server. We have kind of a Fed-centric legality page if they hit it. We're going to want Ganglia set up. Systat. Systat is for SAR.
Yep.
And at this point, by the way, when we get into basically Ganglion on, the instrumentation I'm going to have you do on your own, and then we'll regroup and do it as a group.
Okay.
So the Ganglia, the Systat, the PCP will be yours. SGI has something called SSMC. I'm not worried about that right now. It's a web GUI to get into the ISSP. And SSMC does plot PCP data. But again, the prior line, I got to be careful because SGI has something called PCP-storage, which is different than other PCPs. But let's get to that later. I need BNC. I don't know that we're going to have any sudo on this. Sudo just allows me to let somebody go root without sharing a real root password. And that way I can protect my root password and take them off the list without changing secret passwords. Again, I like to keep the firewall down until we try to put it up. We're going to want to turn off things like the sound. Right now, I'm going to leave transparent huge pages on. And one of the hard parts right now that I've been doing is trying to review the kernel boot options, KDump and things like that. There's a whole bunch of options that SGI adds in there that I'm not getting by default. I need to look at them more closely. I do not plan on any iSCSI for this box.
All right.
So this is kind of my spec. Is that the end of it?
Yeah, it should be.
Always tough using 2 screens and getting from one screen to the next.
Yep.
Now, after this next slide, we'll take a short break.
Okay.
I was trying to get Tom involved more. And he's had over a month, but he just hasn't been focused enough. So this is what we got. Not counting those 2 4-terabyte drives that are in NFS server, but this is what's in Ford 1.
Okay.
So up in the upper left, I got my root device. And then the second drive has CentOS on it right now.
Mm-hmm.
Now, I've got another 1 terabyte DOM SSD drive sitting there that I ordered for Thought 2, which I still kind of want to put into Thought 2. But if this is higher priority, I could put that there if I need a terabyte SSD.
Sure.
But right now, I'm not planning on that. But one of the problems on these others was temp filling up root, and that's why on Deep One we went to a terabyte DOM. We just haven't interrupted Thought to do the same thing. And maybe I decide that 1 terabyte DOM is more useful somewhere else.
Sure.
So then we got our 1.6 terabyte, 2 of them. Home and Journal have to be on 2 separate disks for reliability.
Yep.
And then we got our temp, our backup, and our spool. Then I've got my home RAID 5 on the NVMEs. And then I've got, and this is where I'm still playing here. Now, one thing keep in mind here are boundaries. There are 30 drives at each port on this RAID controller. I really don't want a LUN to cross between those 2 ports.
Okay.
Now, some people might go rotate between the 2 ports. So take one from each, and rotate to spread their LUNs across the 2 ports in a round-robin distribution fan-out kind of design.
Mm-hmm.
But I don't want to do that here.
Okay.
In order to find my LUNs to be on a 30 boundary, and if you look there, I've got 6, 8 plus 1, that gives me like 54.
Mm-hmm.
What did we have here? Why is my math wrong? 1, 2, 3. Well, anyways, I've got something wrong with my drawing. It's not enough drives, is it?
I've got
30, 60. What's that?
No, I was just counting out to myself.
So I've got 6 of these LUNs. I want to make sure that the third LUN there ends on 29. And then the next LUN, I'm starting at LUN 3 because I could put them at the beginning or the end of each controller. That's kind of what I'm saying. But in terms of building them, I'm going to build those 3 spindle LUNs first so that the RAID 5 LUNs end up on a controller port boundary. I don't know, you following that?
I think so. I'm still a little bit fuzzy about why. I think I understand why, but I want to make sure. Why don't you want to have have 2 controllers involved, and as opposed to just one?
Well, that's just a kind of a call shot. The main reason was I modeled mine after the SGI appliance, which they stopped shipping, the ISG, and they put their DMFs round robin between the 2 controllers, but they put their large sequential. Again, a lot of this is latency versus bandwidth. So by putting them, the LUN all on the same controller is more of a bandwidth thing.
Mm-hmm. Okay.
And simplicity, I might add. So we're going to see what we actually get when we're done.
Okay.
But what my big concern was, I didn't want one of these LUNs. When you're striping and rating and stuff, you want every drive to be identical. You can't replace a drive with a different vendor or anything. They got to be in tune and on boundaries. So I didn't want one of the LUNs that was built differently than the other LUNs because it crossed a controller port boundary. Does that make sense?
Yeah.
And I just decided let's do the 3 ones first. Now, in reality, and so I'm actually going to rebuild these. So in order for me to get the LUNs to start on 3 and stuff, I'm going to build one of the LUNs 3 wide, then build my 3 RAID 5 LUNs, then build 3 again, and then build my 3 LUNs. And this should give me and we will physically see it to be on a controller boundary, a port boundary. So we'll see as we get to that. but I am going to redesign that. I had to do 3 and 3 just so that the Lunds come out the same.
Mm-hmm.
But in the end, I only need one DMF move, and I need everything on archive, so I'll be tearing apart those. Once the other Lunds are built, then I can delete those 2 Lunds and redesign them.
Okay.
I'm doing a lazy way to get the boundaries rather than going expert mode.
All right.
Okay. So I think we should take a break here.
Sure. A quick.
Let's stop the recorder.
Yep.
And